Hello everyone, welcome back into your channel for your academic contents. In today's video we're going to be looking at pulley, okay? Yes, pulleys in Newton's second law. It's whereby our string that connected our objects are running through the pulley, okay? Yes. This whereby today we're going to be looking at three blocks running in a surface, in a horizontal surface, okay, connected along a pulley, okay, or running along a pulley. It's quite complex, but you know that this is frictionless pulley, meaning that there's no friction incorporated to the pulley, okay? Yes, objects are moving freely, and in the end, please don't forget to subscribe to the channel. Please subscribe, just click the subscribe button. Thank you so much. Let's get into the topic. Okay guys, so in this scenario, okay, we have our block X, Y, Z connected in the very same system but in different strings, okay? Look, why I'm saying different strings, because I want to emphasize the fact that the tension between Y and X, okay, is not the same between the tension between Y and Z, because that's not the same string, okay? But it's a connected system, okay? So meaning that the acceleration is the same of all of these objects in the system. The acceleration is the same, but the tension here, and here, okay, look, the tension here, let me use this, okay? The tension here at Z, the tension here and here is the same, yes, but the tension here and here, this side, is not the same, no, okay, because these are different strings, or the tension here and here, it's not the same, okay? Then you get me. So so those are the fundamentals that we have to first understand in dealing with this type of equation. So let's waste no answer, so let's waste no time. Frictionless pulley, okay? So this is a frictionless pulley, there's no friction, and there's no friction on the surface either, okay? Yes, the only opposing force might be a tension or something like that. So not a friction, okay? Yes, so let's jump into our answers. So for our answers, I'm so sorry. So for our answers, we have number one. So number one say calculate the acceleration of the 3 kg block marked X. So let's calculate the acceleration of the 3 kg block marked X. Okay guys, please listen carefully and please inhale some air, okay, before listening here, because this is quite tricky for some students, but some might be perfect right now, okay? Yes, but in most cases this is kind of tricky. So the question says calculate the acceleration of the 3 kg block. Mind what I said to you. I said the acceleration of all of these blocks here, this Y and Z, even this X, is the same. So if ever they say calculate the acceleration of marked X, meaning they calculate the acceleration of the system, that's the very same thing, okay? Okay, so guys, I'm so sorry, while I was explaining, my camera just went off, okay? So sorry, I didn't even notice. Okay, so I was saying these are our answers. Okay, so we have to create or form a very first equation from using block X, okay? Yes. And this was our answers. You can see that for block X, net forces acting on block X, I draw a free body diagram for you to show all forces acting on that block X, which is the essential forces are vertical forces, which is tension force only, okay, as you can see, being pulled by block Y. So that's it. Ft is equal to 3 multiplied by acceleration, okay? 3 kg, so we have two unknown values there, Ft, which is the tension force, and the acceleration. So we have to move to block Y. That's what I was saying. I'm so sorry guys, we didn't notice that my camera is off. So for block Y, so for block Y, F net is equal to MA. Okay, what are the net forces acting on that? Okay, so for block Y, let's say here, this is Y. For block Y, we're going to have gravitational force, a normal force, gravitational force. We're going to have a tension force that favors the motion, and the tension force that is opposing the motion. Okay, so this is the tension force of Y, okay, of YZ. This is the tension force of XY. Okay, yes, of block X to Y. Okay, yes, this is the force of block Z to Y, because Y is pulling, Z is pulling Y. Okay, yes, move this way. So that's how it goes. There's no friction as it is given. So we have there, we're going to have F T, okay, YZ minus, okay, FTYZ minus the opposing force, our FT XY is equal to MA. What's the mass? 3 multiplied by A. Mind you, we said our FTX XY, okay, our FTXY is equal to 3A, okay, alright, okay, so this becomes FTYZ minus 3A is equal to 3A. That's how it goes. Think with me guys. So this becomes 6A that side, because we have to take this 3A like terms into the right hand side, so it becomes 6A. Okay, so our FTYZ is equal to 6A, and this becomes the equation of Y. Okay, yes, equation 2. So let's move to look for block Z. Okay, now we're looking for block Z because the system is showing the same acceleration, and in this state we can't determine our acceleration of this box because there are still unknown values, 2 unknown values there, as you can see. The FT of the FTYZ, okay, this tension here by this string is unknown, and the acceleration is unknown as well, so we can't substitute anything from there, okay, other than substituting FTXY, which is equal to 3A. Okay, yes, so meaning that we're moving. So for block Z, okay, the very first thing we should do, we have to draw a free body diagram for box Z. Okay, yes, a free body diagram for box Z. So for block Z, let's draw it here. Let's just say okay, let me not draw it here. Okay, let me just draw it here. So let's just say Z. Okay, yes, so for Z, okay, there are only forces acting vertical there because it's not on the surface. There's a gravitational force which is positive, pulling it downwards, okay, which is equal to weight. And you might ask yourself, hey sir, why is 4 kg block pulling 2 3 kg blocks? Because the mass of this and this is bigger than the 4 kg. It's because the answer is simply because, I think I told you this last time, it's because your 4 kg block, okay, it's being pushed down by a gravitational force. Okay, it's being pulled down by a gravitational force, meaning that it's being assisted by a gravitational force, which is its weight. Okay, mass multiplied by gravity, but here the gravity is balanced, so that's why it's being able to pull these two. Okay, and then you understand and you get it. Okay, so this is the tension force. Okay, This is F T Y Z. This is F T Y Z. So these are the only forces acting on Z in the 4 kg block. Okay, yes. So we're going to say okay, F net is equal to MA. What's the net forces there? The net forces there are the gravitational force is positive, gravitational force minus what? Minus FTYZ. Okay, minus this FTYZ because Y is pulling back Z. Okay, FTYZ is equal to 4A. What's our FG? Our FG is our mass multiplied by the gravity. Let's go calculate it. So Fg is equal to mg, and this is equal to 4 multiplied by 9,8. This is equal to 4 multiplied by 9,8. Let's press on our calculators. 4 multiplied by 9,8. It's 39,2 newtons. Don't forget the units, guys. Newtons. Okay. Think you still with me, guys? Please don't get lost. Okay, so it's 39,2 minus FTYZ is equal to 4A. Okay, what's our FTYZ? I think we received our FTYZ. Our FTYZ is equal to 6A from our equation 2. So our FTYZ, we have to substitute there, minus 6A is equal to 4A. So this becomes 39,2 is equal to 10A, because negative 6 go to the side positive, so 4A plus 6A becomes 10A. Divide by 10, divide by 10. Therefore, our acceleration is equal to, let's press on calculator, 39,2 divided by 10. What's the answer? The answer is 3,92. It's 3,92 meters per second. 2 meters per second. That's how it goes. So this is the acceleration for block X. Okay. So now the question 2 says, calculate the tension in the rope between X and Y. So let's calculate the tension between the rope X and Y. So it's very easy again. So in order for us to calculate the tension for X and Y, we have to use this one, okay, and substitute our 3A. Okay, it's easy. Or you can use that one. Which one? Okay, but the easiest way, because this is kind of complicated if we're going to look for Y and Z for you. So the easiest way is to use this one. Okay, because the acceleration is there, everything is easy. So there's only one force acting on X, meaning that it's that force that we are required to calculate. The force, the tension force that's acting between X, Y, okay, in this rope. Okay, so F net is equal to MA. These are marks, guys. The formula is marks. So FT XY is equal to 3, okay, multiply by what? Multiply by 3,92, and our tension at XY is equal to 3 multiplied by 3,92 multiplied by 3,92, and this becomes 11,76 newtons. 11,76 newtons. And therefore our tension force at XY, our tension force here, it's 11,76 newtons. Okay, so let's move to number 3. We are going to calculate number 3 this side. Okay, I think we still have so let's just say number 3 here. Yes, let's say number 3 here. So for our number 3, calculate the resultant force or net force of the block marked Y. Okay, let's calculate the net forces acting on Y. So we are going to say F net. These are marks, guys. Formula, okay. 10 second formula. So you know that this is for y. So we have your f t y z, which is positive, minus f t x y, which is negative, is equals to ma. So the unknown value here will be 1, will be only this ftyz, okay? And ftyz must be bigger than ftxy, okay? Because ftyxy is opposing the motion, it must be a smaller value or a smaller magnitude, but ftyz must be bigger because the motion is moving to this side, okay? Yes, to the right side. I think you get me. So please check that. So ftYz is unknown, minus, okay, minus, you can also check it here, ftxy, and substitute you can also say ftyz is equal to 6a, you can substitute here, okay, yes, you can just substitute here. You can just substitute the acceleration here and get your ftyz, but the most brilliant way is to use this way because you're going to receive marks there, okay? Yes. So xy, what's it? So it's what's your xy? Xy was 11,76 newtons, is equals to 3 multiplied by acceleration. Our acceleration is 3,92 meters per second. So this becomes ftyz is equals to, is like that. So let's press on your calculator. 3 multiplied by 3,92. So 3 multiplied by 3,92. So that gives us 11,76 again. 11,76. So 11,76 plus 11,76 plus 11,76, that gives us 23,52. So that gives us 23,52 newtons. So you can see that the tension here is, the magnitude of the tension here is indeed bigger than the tension here, okay? You know that, yes, this system is moving to the right side, okay? So that's how it goes, guys. I think we're done. The other way, I think you can substitute here, okay? Yes, substitute 6 a, okay? Then I think you'll receive the very same thing. So that's how it goes. Yes, so let me just do it for you. By substituting there, okay? Or you can just say, but this one is a lot of marks because you're going to receive marks for using this one. Just to also check it in subjective ways, you can say ftyz is equal to 6a. This is equals to 6 multiplied by 3,92, or acceleration is equals to, so pressing your calculator, 6 multiplied by 3,92, that gives us 23,52. Same thing, very same thing, guys. And that's it. That's the end of the lesson video. Thank you so much for your ears, guys. I'll see you in the next following video. More content is coming. Please don't forget to subscribe. Cheers. See you.